Okay, so really, I'm hoping you're thinking that so far, what we've used with De Moivre's theorem is actually not very interesting. It's just the same as the things we've been doing previously. But we are going to try and apply De Moivre's theorem to many more interesting things that don't seem as obvious as perhaps those previous examples did. So we're going to try and use it to come up with some weird and wacky trig identities. And the first thing we're going to do for the example is we're going to try and express cos 3 theta in terms of powers of cos theta. In other words, it wants the question to be in terms of things like it could be a cos cubed theta, something to do with cos to the power of 5 theta, all sorts of things as a combination of that. I'm probably thinking, how on earth are we going to do that? So we're going to have a look at doing this by using these three steps that I've got. I've said create a De Moivre statement that includes a cos 3 theta on the right hand side. We're then going to do something to do with binomial expansion, and then we will compare real and imaginary parts. All of these things will make a lot more sense when we get started. So the first thing I'm going to do is to come up with a De Moivre statement that includes a cos 3 theta on the right hand side. So I know that something that has a cos 3 theta is also going to have an I sine 3 theta, which means that the other side must be a cos theta plus I sine theta all cubed. Okay, we know that when you are cubing this complex number, you would just multiply the arguments by 3. So you end up with cos 3 theta and sine 3 theta. So that's the first step done. The next thing we're going to do is binomial expansion on cos theta plus I sine theta all cubed, okay? And you'll see why we do that in just a second. So when I do this cubed, I will start off with the first term, which is cos cubed theta. And again, I guess you could think of Pascal's triangle for this one, but you should know that for cubing, it will be, the coefficients will be 1, 3, 3, and 1. Then my next bit is going to be 3 multiplied by cos squared theta multiplied by I sine theta. My next bit is going to be 3 cos theta multiplied by I sine theta squared. And my last bit is just going to be I sine theta all cubed. So I'm going to tidy this up a bit. I've got cos cubed theta plus 3I cos squared theta sine theta. Now, just carefully evaluating this bit, I have an I squared, so it's going to make this whole thing negative, minus 3 cos theta sine squared theta. And then I cubed is actually going to be minus I. I cubed is minus I. So it's minus I sine cubed theta. So now we have this statement. Okay? And I also know that this thing here is the same as this thing here. So I'm just going to write that out. That cos 3 theta plus I sine 3 theta must be equal to this thing. But I'm going to write this thing with the real parts together, like I have here, and the imaginary parts together, like I have here. So the real parts are this, and the imaginary parts are this and this. This is going to be for the imaginary, and this is going to be for the real part. So I'm going to get cos cubed theta minus 3 cos theta sine squared theta plus I 3 cos squared theta sine theta minus sine cubed theta. So clearly, by comparing the real parts, I can see that cos 3 theta must be equal to this, and by comparing the imaginary parts, sine 3 theta must be equal to just the bit that's inside the brackets that we've got here. But they only wanted us to, we've done the binomial expansion, and now we're doing the comparing of the real and imaginary parts. All we want to know about is the cos 3 theta part. So that is actually just going to be the real part of this whole thing. So cos 3 theta is going to be equal to cos cubed theta minus 3 cos theta sine squared theta. You're allowed to do that. If you have a complex number that's got a real and an imaginary part, the real parts must be the same and the imaginary parts must be the same, otherwise they wouldn't be the same complex number. So we haven't quite done what the question wanted, because it wanted it to be in terms of powers of cos theta, and I've got a sine squared theta in there. So I'm just going to continue working on that sine squared theta, and I'm going to replace the sine squared theta with its identity, which is 1 minus cos squared theta. So I get cos cubed theta minus 3 cos theta plus 3 cos cubed theta, which overall will give me 4 cos cubed theta minus 3 cos theta. And that is what cos 3 theta is actually equal to. There's an alternative way you could have done this, but they've asked for de Moivre's theorem, really. We could have said that cos 3 theta is the same as cos 2 theta plus theta, and then we could have done the addition formulae. And you'd have to do the addition formula again for this bit, and you would come up with the same statement that we've got here. It hasn't asked for it, but we can see that sine 3 theta is the bit that I've got in green at the end, which is 3 cos squared theta sine theta minus sine cubed theta. And again, I could replace the cos squared with 1 minus sine squared if I really wanted to. So I'm going to do another example of this, and then you're going to do some practice, an exam question practice. So this time we want to express 6 cos theta in terms of cos theta, and this is going to be a lot more work because of the fact it is a 6 theta. So I'm going to start off by coming up with my de Moivre's statement, which is that cos theta plus I sine theta to the power of 6. We know that that is going to be the same as cos of 6 theta plus I sine of 6 theta. So I'm going to do binomial expansion on this bit on the left-hand side. So cos theta plus I sine theta to the power of 6. Well, I know I'm just going to have cos to the power of 6 theta to begin with, plus 6 choose 1, cos to the power of 5 theta multiplied by I sine theta, plus 6 choose 2, cos to the power of 4 theta times I sine theta squared, plus 6 choose 3, cos cubed theta I sine theta cubed, plus 6 choose 4, cos squared theta times I sine theta to the power of 4, plus 6 choose 5, cos theta times I sine theta to the power of 5, and 6 choose 6 is just 1, so it's just going to be I sine theta to the power of 6. So let's do some simplifying. That's cos to the power of 6 theta. Now 6 choose 1 is obviously going to be 6, but I'm just going to show you. 6 choose 1 is 6. This is coming up with the coefficients. So I have 6 multiplied by I cos to the power of 5 theta sine theta. I'm dealing with this first one here, okay? Now my next one is 6 choose 2. I'll tell you what, why don't I just come up with all of those coefficients for a second. So it goes 1, 6, let's do 6 choose 2, which is 15, 6 choose 3 is 20, 6 choose 4 is 15, which means 6 choose 5 is 6, and then the last one is 1. So these are our binomial coefficients, okay? Let's keep going. So I'm going to have, I've done the 6, it's going to be 15 cos to the power of 4 theta. I'm going to have sine squared theta, but I've also got I squared. Now we know that I squared is actually minus 1. So this is going to be minus 15. You may like to write this kind of thing down where you have I squared, I cubed, I to the power of 4. So we get I minus 1 minus I, 1, I to the power of 5 is I, and it just goes around in that cycle, okay? So let's keep going. Not an easy question. So 6 choose 3 is 20, so it's 20 cos cubed theta. I cubed is minus I, so I'm actually going to just adjust this bit at the beginning. It's going to be minus 20I sine cubed theta. I'm going on to the next part, which is going to be a coefficient of 15. So it's 15 cos squared theta sine to the power of 4 theta, because I to the power of 4 is 1. Now my next one is just going to be, I to the power of 5 is going to be I. So there's going to be a 6I cos theta sine to the power of 5 theta. I'm evaluating this term at the moment. And then I have I to the power of 6, which is just going to be minus 1. So it's just going to be minus sine to the power of 6 theta. It's a lot of work. So this thing is the same as this thing. So I can say that cos to the power of 6 theta plus I sine 6 theta. I'm going to write the real parts first. The real parts are this, this, and this, and this. So it's cos to the power of 6 theta minus 15 cos to the power of 4 theta sine squared theta plus 15 cos squared theta sine to the power of 4 theta minus sine to the power of 6 theta. But they only want it in terms of cos theta, which means I need to remove the sine bits that I've got here. And that's going to be pretty annoying. So for the rest of my calculations, instead of writing cos theta, I'm going to write it with C. And instead of writing sine theta, I'm going to write S to save me a bit of time. So I've got C to the power of 6 minus 15 C to the power of 4. Now sine squared is 1 minus cos squared. I've then got 15 cos squared. Now sine to the power of 4 is actually going to be sine squared all squared. Okay, sine squared is 1 minus cos squared, and I'm squaring it. And I'm going to minus sine to the power of 6, which is sine squared cubed. So I get cos to the power of 6 minus 15 cos to the power of 4 plus 15 cos to the power of 6. Then for this next bit, I'm going to have 15c squared. If I do 1 minus c squared all squared, that is going to be 1 minus 2c squared plus c to the power of 4. And this next bit is going to be 1, oh my goodness, minus 3c squared plus 3c to the power of 4 minus c to the power of 6. Okay, so you've got to be really careful with doing binomial there. You should be able to do cubed in your head. I think I've done that right. I have done that right. Yep. So gathering this all together, that's c to the power of 6 minus c to the power of 4 plus 15c to the power of 6. Expanding the brackets is 15c squared minus 30c to the power of 4 plus 15c to the power of 6 minus 1 plus 3c squared minus 3c to the power of 4 plus c to the power of 6. Just going to be really careful now about adding all of these things up. Okay, so for the power of 6's, and I'm going to tick them off as I go, I've got 1, 16, 31, 32, c to the power of 6. So that's 32 cos 6 theta. Then I'm going to do c to the power of 4. So that's minus 15 minus 30, that's minus 45 minus 48 for this. So it's minus 48 cos to the power of 4 theta. And then my last ones are for the squared. So that's 15 plus 3, that's minus 12. Oh, not minus 12, sorry. Is it 12 minus 12? No, it's plus 15 plus 3, so that's plus 18 cos squared theta. And I've got a minus 1 at the end as well. I mean, that's some heavy work. But you can use this little trick to save you a bit of time with all of that expansion and things that's going on there, okay? I hope I haven't made a mistake. I really hope I haven't made a mistake. Okay, and then it wants us to work out what sine of 6 theta over sine theta is in terms of cos theta. So, hang on a second, have I just grabbed the real parts? Yeah, this shouldn't actually say all of this. This should have said that cos of 6 theta is equal to this. It's just talking about the real parts that I've got. So everything I wrote there was the real parts. So now I'm going to say that sine of 6 theta is just going to be the imaginary part of this thing that we wrote at the top here. So sine of 6 theta is going to be the imaginary part. Cos of 6 theta was the real part. So sine of 6 theta is going to be these other bits that I'm going to grab from here. which is this, this, and this. So we have 6, and I won't have the I anymore because I don't have the I in front of the sine theta. So it's going to be 6 cos to the power of 5 theta sine theta minus 20 cos cubed theta sine cubed theta plus 6 cos theta sine to the power of 5 theta. And they actually want us to find out what sine 6 theta over sine theta is. So I can divide all of those things by sine theta. And I get 6 cos to the power of 5 theta minus 20 cos cubed theta sine squared theta plus 6 cos theta sine to the power of 4 theta. Now I'm going to do that trick again. So this is 6c to the 5 minus 20c cubed, and sine squared is 1 minus cos squared. And then I've got 6 cos 1 minus cos squared all squared for sine to the power of 4. So that's 6c to the 5 minus 20c cubed plus 20c to the power of 5 plus 6c multiplied by 1 minus 2c squared plus c to the power of 4. That is just expanding the brackets of that last bit. So that's 6c to the 5 minus 20c cubed plus 20c to the 5 plus 6c minus 12c cubed plus 6c to the 5. So gathering together all of the c to the 5s, that's 6, 26, that's 32c to the 5. Then for c cubed, I've got minus 20 minus 12, so that is minus 32 c cubed. And then I've got at the end plus 6c. But they wanted it in terms of cos theta, so we better make sure we write this back in the correct form, which is 32 cos to the power of 5 theta minus 32 cos cubed theta plus 6 cos theta. These are pretty demanding questions, okay? So there is an example for here that you could have a go at, and then there's a bit in part B that's about solving the equation, so I might have a look at doing that bit with you as well, okay? Okay, you can pause the video here and have a go, but I'm going to start going through this one now as well. Good, and I've given myself an extra page, which I'm going to need, I'm sure. So we're going to try and do it for sine 5 theta. So my de Moivre's statement is going to be that cos theta plus I sine theta to the power of 5 is cos 5 theta plus I sine 5 theta. So I'm going to keep going and doing the binomial expansion. Now I'm going to very quickly get my binomial coefficients. So I'm going to do 5 choose 1. So it goes, obviously, I'll put it here, it goes 1, 5. 5 choose 2 is 10. 5 choose 3 is 10. 5 choose 4 is 5, and 5 choose 5 is 1. So we've got the coefficients there. That means it's going to be cos to the power of 5 theta plus 5 cos to the power of 4 theta multiplied by I sine theta. So I really should have put an I in here and sine theta. Now I squared is going to be minus 1, so I'm going to get minus 10 cos cubed theta sine squared theta. Then I'm going to be multiplying it by another I, so it's going to be minus 10i cos squared theta sine theta. I'm going to go over to the next line. It is then going to be a plus, because you've got I to the power of, whoops, this should be sine cubed. We're now going to have I to the power of 4, so it's going to be a plus. It's going to be plus 5 cos theta sine to the power of 4 theta. And then our last one is going to be plus I sine to the power of 5 theta, because I to the power of 5 is just I. So we know that sine 5 theta is going to be equal to the imaginary part of cos theta plus I sine theta to the power of 5. And the imaginary part that we've got is this bit, and this bit. It's the alternate bits that we've got there. So that's 5 cos to the power of 4 theta sine theta minus 10 cos squared theta sine cubed theta plus sine to the power of 5 theta. Now I'm going to let cos theta equal c and sine theta equal s. So I get 5c to the power of 4s minus 10c squared s squared plus s to the power of 5. Now we want to get rid of all of the cosines because it's all in terms of sine. So cosine is cosine squared is 1 minus sine squared, but it's to the power of 4, so it's also going to be squared. Then you've got 1 minus sine squared instead of this cos squared that we've got here, all multiplied by sine squared, plus sine to the power of 5. So this is 5s, I'm just pulling this s to the front, 1 minus 2s squared plus s to the power of 4, minus 10s squared multiplied by 1 minus s squared plus s to the power of 5. Expanding the brackets more, you get 5s minus 10s cubed plus 5s to the 5 minus 10s squared plus 10s to the 4 plus s to the 5. Starting with the biggest powers, we have got 6 s to the 5. We then have, is this good? I feel like I should have some cancelling. Let's see if we do. Cos squared sine cubed. Oh, I've seen the mistake I've made. This should be sine cubed here, and I did sine squared. So let's erase some of this. That should have been sine cubed. Very easy to make these mistakes. So we should have minus 10s cubed plus 10s to the power of 5. So for the power of 5s, we've got these, which is 5, 10, and 1, which is 16 sine to the power of 5. We've then got minus 20 sine cubed plus 5s. Yes, that is exactly what we wanted here, so I better just write that out as well. So that is 16 sine to the power of 5 theta minus 20 sine cubed theta plus 5 sine theta. A lot of work. Then we have been asked in part B, it says hence. Also, given that this is true, find the solutions to this equation. Great. So we've got sine 5 theta equals 5 sine 3 theta. Let's just write that down for part B. Sine 5 theta equals 3 sine 3 theta. 5 sine 3 theta. So the left-hand side I've just worked out, which is 16 sine to the power of 5 theta minus 20 sine cubed theta plus 5 sine theta. And the right-hand side is 5 multiplied by this bit that I've highlighted in blue. So that's going to be 15 sine theta minus 20 sine cubed theta. So there's something quite lucky that is going to happen here. The minus 20 sine cubed theta is going to cancel from both sides, so that I'm now going to be left with 16 sine to the power of 5 theta. 5 minus 15 is minus 10 sine theta, and that is all equal to 0. I can then divide everything by 2. I can then factorize by sine theta. So that is going to be 8 sine to the power of 4 theta minus 5, which tells me that either sine theta is equal to 0 or sine to the power of 4 theta is equal to 5 over 8. There's a lot of solutions for this one. Just want to check the range. So they want it between 0 and 2 pi, and they want the answers to 3 decimal places. So I know that sine is equal to 0, and it's not including 2 pi, when theta is equal to 0 and pi. And for this one, sine theta is going to be plus and minus the 4th root of 5 over 8. And it wants it to be in radians, which is good. So I'm going to do the 4th root of 5/8, which I have here. So sine theta is going to be equal to 0.88913, which is going to give me the values of theta. Let's just clear that for a second. Sorry. I'm going to do the inverse sine to this, and I get 1.095 to 3 decimal places. And the other one we know that we find by doing pi minus the answer, which is 2.046 to 3 decimal places. Now the other version is that sine theta could have been negative 0.88913. So I'm just going to go back here. Yep. Let's clear all this. It's annoying me. So it's the 4th root of 5/8. I'm going to use the negative version of the answer, and I'm going to do the inverse sine to that, which is negative 1.095. And I'm also going to do theta minus that, sorry, pi minus that, which is 4.237. But neither of these are in range, so I'm going to add 2 pi to this one and take away 2 pi from this one. Oh no, I wanted it between, it is in range, this one, my apologies, this is in between 0 and 2 pi. But this first one here is not in range, so I'm going to add 2 pi to it. So that you get 5.188, and not this one. So the solutions are 0, pi, 1.095, 2.046, 5.188, and 4.237. What a lot of work that is. I wonder if I can even zoom in and see if these were the right answers. I can see they're roughly right, but I normally make that a bit bigger when I'm doing these in class. Okay, so that's for the first part of the next exercise. Some hard work here.